and those are our rationals. We're asked to find the domain and range of both the original function and the inverse. And here this guy is a rational function. Remember, that's just a fancy way of saying that you have a fraction on steroids. It's got variables showing up in numerator, denominator, everywhere. So rational function, our restricted values come from the denominator. Okay, so this does have restrictions, but we'll take care of the domain and range after we find the inverses. So our first step, we need to replace g of x with our y. So we have negative 5x plus 11 all over 2x minus 3. Step 2 says that we switch x and y in our equation. So x is equal to negative 5y plus 11 all over 2y minus 3. And because we have our y in the denominator, we're going to multiply both sides of our equation by that denominator, 2y minus 3, because we don't want the 2y minus 3 in that denominator anymore. So on the left-hand side, I have x times 2y minus 3 equal to negative 5y plus 11. Okay. Because we have y's showing up everywhere and we need to get our y's to one side and everything without a y to the other side of the equation, we need to take care of this x. We can't divide both sides by x because then we're going to have our negative 5y trapped with the x underneath. So we're going to distribute our x all the way through our parentheses. So we're going to have x times 2y gets us 2xy. X times negative 3 gets us negative 3x. We have negative 5y plus 11. Move everything with an x to the right side, everything with a y to the left. So let's go ahead and add 3x to both sides. When we do that, we're going to have 2xy equal to negative 5y plus 3x plus 11. We need to get all of our y's to one side, so I'm going to add 5y to both sides. Remember, you can skip this step if you're comfortable doing it in your head and go straight to 2xy plus 5y equal to 3x plus 11. And now notice on the left-hand side, we have a y in both terms, which means that we are going to factor out the y. We'll have 2x plus 5 in parentheses equal to 3x plus 11. Divide both sides by that parenthesis, and we get y is equal to 3x plus 11 all over 2x plus 5, which means that we just found our inverse, which in this case is g inverse of x, is equal to 3x plus 11 all over 2x plus 5. Try circling that without cutting off all my numbers. Okay, we still need to do the domain and range of both of our functions. So I'm going to go ahead and write my chart. And we're going to give ourselves a little bit more room than we did in the last one, our last chart, because we're going to have some longer function domain and range to write. Yeah. So let's find the restricted values of g of x, so the domain of g of x. We're going to take our denominator, set it equal to 0. When we add the 3 and divide by 2, we find out that x cannot be 3 halves. And if you want to do the little number line, you can. And the only number on there is going to be the 3 halves. And remember that you cannot be the 3 halves. So our domain of our function, the original, is negative infinity on up to 3 halves with a parenthesis, union 3 halves to infinity. Notice I didn't even take my own directions, that I needed more room. So here we go. And of course, technical issue. Sorry about that. Give me a second. There we go. And because we found the domain of the original, we found the range of the inverse. So we get negative infinity 3 halves, union 3 halves to infinity, and make sure that you have parentheses around those 3 halves. Next, let's find the domain of our inverse. Start the same way, take our denominator equal to 0 to find our restricted values. Subtract the 5 and divide by 2, and we find out that x cannot be negative 5 halves. If you set yourself up with the number line, only negative 5 halves is going to be canceling out. So our domain is going to be negative infinity to negative 5 halves, union 5 halves to infinity. And if we found the domain of the inverse, we found the range of the original. Again, negative infinity to negative 5 halves, union negative 5 halves to positive infinity. So you've actually already been working on finding functions with restricted domains and their inverses. It's just it didn't really refer to it in that way, but our rational functions fall into that category.